What you're seeing isn't a watercolor painting in motion. In fact, it's the planet Jupiter. For the most part, this gas giant remains a mystery to us. So what would happen if you wanted to discover it for yourself and jumped right onto the planet? Or should we say into, because Jupiter doesn't have a surface, just a seemingly endless stretch of atmosphere. Would you fall straight through? What would you see on your way down? How would it make you feel? And most importantly, how long would you survive? Let's find out what would happen if you fell into Jupiter. The radiation problem. You're dead before you start. If you attempted to jump into Jupiter wearing a standard spacesuit, it would be over for you pretty quickly. Actually, you wouldn't even make it to the planet itself. Your mission would fail before you even started your descent. Roughly 300,000 kilometers from Jupiter, still a significant distance away, about 3/4 of the distance between Earth and the Moon, deadly radiation would penetrate your suit and kill you. Jupiter has the most intense radiation belts in the solar system, far more dangerous than Earth's Van Allen belts. These radiation belts are created by Jupiter's incredibly powerful magnetic field, which is 20,000 times stronger than Earth's. The radiation is so powerful that it would fry your body's cells at the molecular level, breaking apart DNA, destroying cell membranes, and causing rapid tissue damage throughout your body. You'd experience acute radiation syndrome within minutes. Your cells would start dying en masse. Your organs would begin failing one by one. Depending on your exact location within the radiation belts, death could come within hours or even minutes. Even robotic spacecraft have trouble with Jupiter's radiation. NASA's Juno probe, which is currently orbiting Jupiter, had to be specially designed with radiation-hardened electronics and thick shielding just to survive in Jupiter's vicinity. And even with all that protection, scientists expect the radiation will eventually destroy the spacecraft. But that's a boring what-if scenario where you just die in space before anything interesting happens. So we'll give you a special spacesuit that can somehow survive everything Jupiter throws at it. The radiation, the crushing pressure, the temperature extremes, the corrosive chemicals, everything. It's a magical suit that keeps you alive no matter what happens. Think of it as a what-if miracle suit, because otherwise this would be a very short and disappointing video. Now, with your magical suit protecting you, here's where the real fun begins. The initial fall, faster than you've ever fallen. At first you'll be falling from the top of Jupiter's atmosphere at nearly 180,000 kilometers per hour. To put that in perspective, that's about 50 kilometers per second. You're falling incredibly fast. That's a lot faster than you'd fall from the top of Earth's atmosphere. Why? Because Jupiter's gravity is much stronger than Earth's. Jupiter is so massive, 318 times more massive than Earth, that its gravitational pull is intense. Even though you're starting at the top of the atmosphere, you're already being yanked downward at tremendous speed. You'd still be able to see the sun from this height, a small bright dot in the distance, but don't expect it to heat you up or provide any warmth. At this altitude, you're far from any heat source, and Jupiter's upper atmosphere is extremely cold. The ammonia clouds. Welcome to negative 150 degrees. At about 250 kilometers down into Jupiter's atmosphere, you'd reach the ammonia clouds. These are the beautiful colored bands you see in pictures of Jupiter. Swirls of white, orange, brown, and red that create those stunning patterns we observe from Earth and space telescopes. But beautiful or not, you'd be experiencing temperatures of negative 150 degrees Celsius. That's far colder than the coldest temperature ever recorded on Earth, which was negative 89 degrees Celsius in Antarctica. That's cold enough to freeze carbon dioxide solid into dry ice. Without your magical suit keeping you warm, you'd freeze solid in seconds. Your body turning into a frozen statue tumbling through the clouds. The ammonia clouds themselves are made of ammonia ice crystals, suspended in an atmosphere of hydrogen and helium gas. You'd be falling through clouds of frozen ammonia, the same chemical compound we use on Earth as a cleaning agent and fertilizer. Here on Jupiter, it's just floating around in crystalline form at incredibly cold temperatures, creating those stunning cloud patterns and color variations. The different colors in Jupiter's bands come from different chemical compounds at different altitudes. The white clouds are ammonia ice. The brown and orange clouds contain compounds of sulfur and phosphorus, along with complex organic molecules called tholins. The red color in the Great Red Spot likely comes from these same complex organic compounds being altered by sunlight and charged particles. The wind tornado, a giant, colorful whirlpool. Now get ready for the most epic whirlpool of your life. Jupiter's clouds create powerful winds up to 482 kilometers per hour. That's faster than the strongest tornadoes on Earth. You'd feel as if you were caught in one giant, colorful tornado that never ends. The winds would whip you around violently, spinning you, tumbling you, throwing you in different directions. You wouldn't be falling straight down anymore. You'd be caught in massive atmospheric currents that would carry you sideways, upward, then downward again in chaotic patterns. That's because Jupiter is the fastest rotating planet in our solar system. Despite being the largest planet, it spins incredibly fast. One day on Jupiter, one complete rotation, is equal to just 9.5 Earth hours. This rapid rotation creates intense atmospheric dynamics and these incredibly powerful wind systems. The Great Red Spot, Jupiter's famous storm, is actually a massive hurricane-like system that's been raging for at least 300 years, possibly much longer. If you fell through that region, the winds would be even more intense, potentially reaching speeds of 680 kilometers per hour. The Galileo probe, depth, deeper than any human mission. Let's go down about 120 kilometers more. You're now at around 370 kilometers deep. Congratulations! This is the deepest that any human-made exploration has ever sailed into Jupiter. In 1995, NASA's Galileo probe made it this far before it was destroyed by the crushing pressure of Jupiter's atmosphere. The probe sent back valuable data for about an hour before the extreme conditions crushed it like an empty can. But don't worry, that's not happening to you. You've got your magical suit that can withstand anything. You keep falling. Lightning and darkness. The only light you'll see. The further you travel into Jupiter, the darker it gets. Eventually it becomes completely pitch black. There's no sunlight penetrating this deep. You're falling through absolute darkness. The only source of light you'll have will be from the lightning storms happening all around you. And Jupiter's lightning is spectacular, far more powerful than Earth's. Lightning bolts crack through the darkness around you, briefly illuminating the swirling clouds and atmospheric chaos. These aren't ordinary lightning bolts. Some of Jupiter's lightning strikes are up to 3 times more powerful than the strongest lightning on Earth. The flashes would be blinding when they occur. Then you'd be plunged back into darkness until the next strike. At this point, something interesting starts happening. The temperature begins to increase. The deeper you go, the warmer it gets. The extreme cold of the upper atmosphere is behind you now. The pressure of all that atmosphere above you generates heat, and you're starting to feel it. It might even feel comfortable, temperature-wise, if it weren't for the immense physical pressure you're experiencing. The crushing pressure, 1,000 times Earth. The pressure you'd be experiencing now is more than 1,000 times higher than the pressure on the surface of the Earth. Imagine the weight of the entire atmosphere pressing down on you from above. That's similar to being a kilometer deep in Earth's oceans, except you're in gas and supercritical fluids instead of water. The only way you'd be able to survive this is if your spacesuit was built as strong as the deepest diving submarine ever created. And even that might not be enough. The pressure keeps increasing the deeper you fall. Your magical suit is keeping you alive, but you can feel the pressure. It's like being squeezed from all sides simultaneously. Every movement feels difficult. The atmosphere around you is so dense now that it barely feels like gas anymore. It has substance and weight. 12 hours of falling. You're getting bored. By now, you've been falling for approximately 12 hours. And let's be honest, you're getting a little bored. You've been dropping through endless atmosphere for half a day. The lightning storms are impressive, but after 12 hours, even those start to feel repetitive. You'd probably want to radio someone to come and get you. Maybe call for an extraction. Tell them you've seen enough and you'd like to go home now. Well, that's too bad. That's an impossibility inside Jupiter. Radio waves get absorbed this deep into the planet's atmosphere. The dense material around you blocks electromagnetic signals. You can't communicate with anyone. You're completely isolated. falling alone through the darkness with only lightning for company. You'll just have to keep falling. There's no way to stop yourself, no solid surface to land on, no way to call for help. You're committed to this journey now. Supercritical fluid, not quite liquid, not quite gas. The temperature keeps rising and so does the pressure. As you reach the inner layers of Jupiter, things get even stranger. You'll encounter parts of the atmosphere that you could actually swim through. This is supercritical fluid, a strange substance that's not quite liquid and not quite gas. It exists in a weird in-between state that doesn't occur naturally on Earth except in very specific laboratory conditions. Supercritical fluid has properties of both liquids and gases. It's dense like a liquid but flows like a gas. Moving through this strange material would feel bizarre, like swimming through air that has weight and resistance. The temperature will get even hotter as you descend through the supercritical fluid layers. We're talking seriously hot now. Eventually the temperature will become equivalent to the surface of the sun, around 5,500 degrees Celsius. If that isn't enough to worry about, you'll also be experiencing pressure equal to 2 million times the pressure on Earth's surface. 2 million times. That's the kind of pressure that can transform the molecular structure of materials, crushing atoms closer together. Metallic hydrogen, trapped in strange matter. At these extreme pressures and temperatures, hydrogen, normally the lightest element and a colorless gas, transforms into something completely different and exotic. Metallic hydrogen begins to form around you, and soon you'll be completely surrounded by it. This is a relatively unknown and exotic substance that scientists have only recently been able to create in laboratories for brief moments. Under normal conditions on Earth, hydrogen is the lightest element in existence, a colorless, odorless gas that floats away at the slightest opportunity. But under the crushing pressure deep inside Jupiter, pressures millions of times greater than Earth's atmosphere, hydrogen atoms are forced so incredibly close together that their electrons break free from individual atoms and become free to move around. When electrons can move freely like this, the material conducts electricity like a metal does. Hence the name, metallic hydrogen. It's hydrogen acting like a metal, which seems impossible, but is exactly what happens under these extreme conditions. Metallic hydrogen would appear as a dense, silvery liquid that you won't be able to escape from easily. It's significantly more dense than the atmosphere and supercritical fluids above you. If you try to swim upward through it, fighting against the current to escape, you'd be working against incredible density, pressure, and your own exhaustion. Even with your magical suit protecting you, you'd essentially be trapped in this ocean of metallic hydrogen, falling deeper and deeper, and it's not a short distance. Scientists estimate that Jupiter's metallic hydrogen layer could be thousands and thousands of kilometers thick. You might be falling through this exotic metallic ocean for another 12 to 24 hours or even longer. The journey through the metallic hydrogen layer would be mind-numbingly monotonous. You've already been falling for 12 hours through the upper atmosphere, and now you have potentially dozens more hours of descent ahead of you through this strange metallic liquid that doesn't exist naturally anywhere else we know of in the universe, except in the interiors of giant planets. The boredom would be absolutely overwhelming. The isolation would be complete and total. Just you, endless darkness, crushing pressure, and eternal falling through an alien ocean of metallic hydrogen. The core, the end of your journey. Eventually, after falling for possibly days, you'd reach Jupiter's core. Scientists aren't entirely sure what Jupiter's core looks like. Some predict it could be a solid object, a rocky or metallic core compressed by the immense pressure of everything above it. Others think it might be a dense region of heavier elements, but not truly solid. Regardless of what it actually is, if you somehow did manage to survive all of this and reach the core, you'd have a new problem. You'd be stuck there. The atmospheric pressure at Jupiter's core is so immense that you'd be pinned to whatever surface exists there. You couldn't move. You couldn't stand up. The weight of Jupiter's entire atmosphere would be pressing down on you from above, holding you in place like an insect trapped under a heavy book. And remember, you can't radio for help. You're trapped at the center of Jupiter, unable to move, unable to communicate, with no way to escape. You'd be stuck there forever. or at least until your magical suit's life support eventually failed. Not a very rewarding trip, is it? Toss. Conclusion. Leave Jupiter as a mystery. So that's what would happen if you fell into Jupiter. You'd plummet through zones of extreme cold, then extreme heat. You'd be battered by winds faster than any tornado on Earth. You'd experience pressure that would crush any normal spacecraft. You'd fall through exotic materials that don't exist anywhere on Earth. You'd be surrounded by darkness and lightning for hours or days. And ultimately, you'd end up trapped at the core, with no way to escape or call for help. Maybe we should leave Jupiter as a beautiful mystery after all. It's stunning to look at from a distance, with its colorful bands and great red spot. But up close and personal, it's a nightmare of extreme conditions that would kill you in countless creative ways. Jupiter isn't a place for humans. It's a place for study, for wonder, for admiration from very, very far away. The only safe way to explore Jupiter is with robotic probes that can send back data before they're inevitably destroyed by the planet's hostile environment. If you enjoyed this journey into the most inhospitable planet in our solar system, subscribe for more explorations of places that are fascinating, but absolutely deadly, and leave a comment about which planet you'd least want to fall into. Stay safe out there, and appreciate solid ground while you have it.